So homework 17 now is jumping into the polynomial section of your pie chart, so we'll move over a little bit. It is all on solving equations, and that if it's in factored form and it is set equal to 0, that you can set each of your factors equal to 0. Normally, you look to see how many variables you have. If you have 2 variables, you're going to have 2 solutions. If, like on number 3, you have 3 variables, you're going to have 3 solutions. So in this case, I'm just going to break this down into 2 really easy problems. Either the 5y plus 4 could equal 0, or the 1 plus y could equal 0. And then I solve both of those. So I have to minus my 4 and divide by my 5. So one of my answers is negative 4/5. Over here, I'm just going to move my 1 over. So minus 1 would be my other answer. So either negative 4/5 or negative 1 would give you values that both would be 0. Now when you look at the second one, notice that that thing in front doesn't have a variable with it. You could say negative 2 equals 0, but it doesn't, so there's nothing really to solve there. Negative 2 doesn't equal 0. So we can just ignore that that's there because there's no variable to solve for. 4w minus 6 would equal 0, or 1 minus w would equal 0. So if we're going to solve the first one, we would add 6 and divide by 4, so w is going to equal 3 halves. 6/4 reduces down to 3 halves. I write 3 halves. 3 over 2, there we go. On the second one, if we're going to solve that, add the w would be the shortcut because then that makes w positive, and so w is just going to equal 1. If you subtract by 1 and divide by negative 1, you get the same answer. So 3 halves and 1 going to be my 2 solutions. Now on the third one, you'll notice that there is a variable with that thing in front of the parentheses. So we're actually going to have 3 problems. Either the 5x could equal 0, the x minus 6 could equal 0, or the 4 minus 3x could equal 0. So if we solve the first one, x equals 0, because 0 divided by 5 is 0. The second one, x is going to equal 6, because we have to add the 6 to move it over. And the last one, four over 3. 4/3, right? We're going to subtract the 4 and divide by the negative 3. So negative 4 over negative 3 is positive 4/3. So when we're solving an equation that is set equal to 0, normally the degree of my polynomial tells me how many answers I'm going to have. A quadratic equation is a second degree polynomial, so I normally get 2 answers. You could graph that, and wherever the graph touches the x-axis, those would be your answers for your zeros, but sometimes it comes out to fractions or other weird things. These ones at first won't, but the other way we can solve it is just by factoring it out. As long as it's already set equal to 0, we're just going to factor our expression. So u squared would be u and u. Since the end is positive, both signs are the same as the middle, a negative and a negative. Factors of 21 that add up to 10, 7 and 3. So either the u minus 7 equals 0, which gives us a positive 7 answer, or the u minus 3 can equal 0, which gives us a positive 3 answer, because of course we have to move our number to the other side. So if you were to put 7 squared minus 10 times 7 plus 21, you get an answer of 0, right? So number 5, if we're going to factor that one out since it's already set equal to 0, factoring v squared plus, that's supposed to be a v, I'm assuming it won't work if it's a u. Make it a v. Fix that for next time. So if I'm going to factor v squared plus 8v plus 12, that factors into what?
V plus 6, V plus 2.
V plus 6 and v plus 2. So when you solve those, v would equal -6 or -2 because we have to do the opposite when we move them over. Right? We know -6 plus 6 is 0. And number 6, if we're going to factor that one out, how's that one going to factor? Y plus 6 and y minus 5. My signs are opposite because the end is negative. Factors of 6 or factors of 30 that add up to 1 of positive 6 minus 5. So if it factors into y plus 6 times y minus 5, my solutions would be -6 and 5. So in the next ones, they're going to give you quadratic expressions that are not set equal to 0. So we want to make sure we set them equal to 0, that we leave our squared term positive. We've never factored anything with a negative something squared. And then that we have it in the right order. So when I move this over here, I'm going to have a positive 5w squared. This has to move, so it's going to be positive 17w. That has to move, so it's going to be plus 6 equals 0. And I have it in what's called descending order, or the best order for my quadratic expression, so that I can then factor it. So factors of 5w squared, 5w and w, or w and 5w. My signs, both going to be pluses. Factors of 6, I want to get 17 in the middle. What should I put in there for that 6? Two and 3, so that I get 15w plus 2w, which is the 17w. So when I solve these, keep in mind, I'm going to do the opposite of this end one, divide by that one, so w is going to equal what? -2/5. I mean, if you want to write it down and write it all out, you can, but I'm subtracting the 2, dividing by the 5, so -2/5. And my other answer is going to be -3, because I'd have to subtract the 3. So number 8, we want to solve that for x. When I move my 7x over to the other side, I have to make sure I put it in the right spot, so it's got to go in the middle. So 4x squared, that's going to become minus 7x, then the minus 2 equals 0, so that I have it in descending order with my squared term first, then my x in the middle, and my -2 I'm in. So factoring that one out, factors of 4x squared. (4x and x). It might be 2x and 2x. We don't know. We're guessing. So we're going to go with 4x and x. My signs? Positive and a negative. Factors of 2. 1 and 2. And if I check that, I get -8 plus 1, which sure enough is -7. So if we solve the first one, x would equal -1/4, because we have to subtract the 1 and divide by the 4. And the second one, 2. Because we just add the 2. So number 9, again, that one is not equal to 0. We want to go ahead and set it equal to 0. So 9v squared plus 30v, and then that becomes a plus 25 to equal 0. So when we factor that one, what do we want to try for 9v squared? 3v and 3v. My signs, both pluses, since both of those are pluses and factors of 25, 5 and 5. So that we have 15v plus 15v, which adds up to 30v. You're going to get the same answer twice because I have the same factors. They'll either call that a double root, or sometimes they'll say something like multiplicity of 2 because it happens twice. So depending on which book you read, different ways of stating that. But really you only have to put the answer in ones. V is going to equal what?
Negative 5 over 3.
Negative 5 over 3. Now the next ones here, I figure they put on your pie chart because if they ask you this question and you can do it, they don't have to ask you about squaring a binomial, they don't have to ask you about factoring, they don't have to ask you about solving an equation set equal to 0. If you can do this, it cuts off about 10 questions from your assessment. So when I solve this, I would do it in a different order than the ALEKS program. The ALEKS program is going to move this over here first and set it equal to 0, but then you've got that negative in front of your parentheses and people forget to change the signs. I personally would just square that first, then move my stuff to the other side. So if I'm going to square that, keeping in mind that means x minus 3 times x minus 3. X times x is x squared. We had 2 times the first times the last, otherwise I have minus 3x plus a minus 3x, which is minus 6x in the middle, and then negative 3 times negative 3, positive 9. So my 2x squared minus 10x plus 4 is equal to x squared minus 6x plus 9. Either FOIL it out the long way, or the shortcut for squaring, 2 times the first times the last. So what they're going to do now is set it equal to 0. So I'm going to move everything over to this side because I want my x squared to stay positive. So I'm going to subtract my x squared, add my 6x, and subtract my 9. So 2x squared minus x squared would be x squared. Negative 10 plus 6 is negative 4x. 4 minus 9 is minus 5. And now I have it set equal to 0, and I can solve that by factoring. That factors into what?
X minus 5.
X minus 5 and
X plus 1.
x plus 1. So my two solutions would be 5 and negative 1. All right, so one question kills a whole lot of birds. No. Let's see here. Must be on number 11. So number 11, same kind of thing. I would start out by squaring that. So 2w squared plus w plus 30 is going to equal, and what's going to be on the right-hand side when you square that?
W squared minus 8
Minus 8w
plus 16.
plus 16, right? Square the first, 2 times the first times the last, and square the last. Or FOIL it out the long way. So again, we want to move everything over here, so we're going to subtract our w squared, add our 8w, and subtract our 16. So what are we going to get?
W squared plus 9w plus 14.
W squared plus 9W plus 14. Now that it's set equal to 0, we can factor it. That's going to factor into
W plus 2 and W plus 7.
W plus 2 and W plus 7, which means my two answers are
Negative
-2 and -7. Here it goes. So number 12, again, we're solving our equation. First thing I probably want to do is get rid of my parentheses. So if I square my v plus 6, I would get
V squared plus 12V plus 36.
So v squared plus 12v plus 36 equals 2v squared plus 4v plus 48. So when we set this one equal to 0, this time we're going to move things over here to the right side since we have the 2v squared over there. So subtract my v squared minus my 12v and minus my 36. So I would get what over there on the right side?
V squared minus 8 plus 12.
V squared minus 8v plus 12. And if we factor that out,
V minus 2,
v minus 2 and v minus 6. Always likes it when I rewrite something. And so my two solutions would be v equals 2 and 6. All right. The next one, say solving a word problem using a quadratic equation with rational roots. Since it has rational roots, it tells me I really don't have to use the quadratic formula. If it had complex roots or some other weird thing like that, I would have to use quadratic formula. But these ones we should be able to set up and solve by factoring out. It says the length of my rectangle is 5 yards more than twice my width. So the length of my rectangle is 5 yards more than 2 times my width, twice my width. L equals 2W plus 5. The area of my rectangle is 63 yards squared. Area equals length times width, so I know that 63 is equal to 2W plus 5 times W. Substituting in the 2W plus 5 for my length. So using my distributive property there, 63 is going to equal 2W squared plus 5W. I've got a quadratic expression. I'm going to set it equal to 0, so I'm going to minus my 63. So 0 equals 2W squared plus 5W minus 63. And I'm going to solve by factoring. So if I'm going to factor that, that's going to factor into 2W and W would be my 2W squared. My signs. We know we're going to have one of each. We just don't know what order they go in yet. A negative and a positive. Factors of 63. 9 and 7. So if we check that, we get 14W minus 9W, and 14W minus 9W, sure enough, is the 5W in the middle. So if I solve that first one, W would equal 9 over 2. Since we're talking about the width of a rectangle, they're going to change that to a decimal. 9 over 2 is 4.5 or 4.5, right? Now if I solve the other one, W would equal -7, but we're talking about the width of a rectangle, so we can't use the -7 answer, right? So we say, oh, that one doesn't work anyway. I know my width is 4.5. I then go back and find my length. So my length would equal 2 times 4.5 plus 5, which would give me 14. So my width is 4.5 or 4.5, my length is 14. If I wanted to double check myself to make sure I had the right answer, if you take 14 times 4.5, what do you suppose you get? 63, right? Because that's what the area is supposed to be. If you didn't get 63, something's wrong. So number 14 says the length of my rectangle is 5 meters less than twice my width. So what's L going to be equal to? 2W minus 5. This time it says the area is 33 meters squared, so 33 is going to equal my length, which is 2W minus 5 times my width, which is just W. Using my distributive property, 33 equals 2W squared minus 5W. And then since I have that quadratic expression, I'm going to set it equal to 0, so I'm going to minus my 33. So 0 equals 2W squared minus 5W minus 33. And then we get to try to factor that. W minus 11
W plus 3.
and W plus 3. That would give us 6W minus 11W, which sure enough is the -5W. We know the one with the plus sign isn't going to work because that's going to give us a negative answer. On the other one, if we solve that for W, we would get 5.5, right? We get 11 over 2, which is 5.5, which is how they're going to want that answer. So my width is 5.5. I still need to find my length. So substituting that in, 2 times 5.5 minus 5 gives me what for my length? 6. 11 minus 5 is 6. And again, if you would take 5.5 times 6, you should get 33 for the area. And because they're not very creative, this looks almost the same. It says the area of my rectangle is 42 yards squared. The length of my rectangle is 11 yards less than 3 times the width. So, how am I going to show the length?
3W minus 11.
3W minus 11. So, my area is 42. That's going to equal the 3W minus 11, which is my length, times my width. So 42 will equal 3W squared minus 11W using my distributive property. And then setting that equal to 0, I have to minus my 42. So we need to factor 3W squared minus 11W minus 42. W plus 7, and W minus 6. That gives me negative 18 plus 7, which is negative 11 in the middle. And which one of those won't give me a solution? The one with the plus sign. So this is the only one that's going to give me a solution. That one's easy to solve. W equals 6. My length then, 3 times 6 minus 11, which gives me 7. And of course, if I take 6 times 7, I get 42. Hey, that's supposed to be my area. The next ones, we're going to solve things with even exponents. So we want to think about when we square something. If you square a positive 2, you get 4. If you square a negative 2, you also get 4. So if you have a positive number here, you're going to end up with 2 solutions because it could be plus or minus that number. If it's a negative number here, nothing squared is negative, you're going to end up with a no solution. So if x squared equals 63, x is going to equal plus or minus the square root of 63, since the square root is opposite of squaring. They're, of course, going to make you simplify that if you can. 63 we could factor into 9 and 7. And so I'm going to have plus or minus 3 square root of 7. Unfortunately, on Alex, they don't give you the plus or minus option. You have to put it in as 2 answers. So you're just going to say 3 square root of 7, put a comma, negative 3 square root of 7. Be careful that after you do the square root of 7, you hit the space bar or something so that the comma doesn't keep going underneath the square root and you get one big long line over the last part of that so it goes in correctly. Number 17 then, if we have x squared equals 15, and we're going to solve that for x, x would equal plus or minus the square root of 15. Can we simplify the square root of 15? No. So we're going to say x equals the square root of 15 or negative square root of 15. And on number 18, if we have x squared equals negative 75, where x is a real number, my answer is going to be no solution. If I did the square root of negative 75, I'd get an imaginary number, not a real number. So we know right away we can just say no solution. And the last 3 on this page is really getting you ready to do graphing stuff. So I don't know why they put it in here. They did it just for fun, I guess. It's something you need to know when you're graphing a circle or sometimes doing a parabola and all of that good things. They want to make this expression a perfect square so that if you factor it out, you get the same pair of factors twice. To do that, you're going to take half of your middle coefficient, I'll abbreviate, and then you're going to square it. So in this case, half of negative 12 would be negative 6. A negative 6 squared is a positive 36, right? Negative 6 times negative 6 is positive 36. So that if I factored that, it factors into x minus 6 and x minus 6, or x minus 6 squared, which is what we're going to end up having to do when we graph a circle and those kind of things. So number 20, if I am going to make that expression a perfect square, what number is going to go in the box? 25. Half of 10 is 5, and 5 squared is 25. Number 21, what number goes in my box? 1. Half of negative 2 is negative 1, and a negative 1 squared is positive 1.